Hi, and welcome to the session. Today, I want to talk to you about how you can jumpstart your journey in learning Tableau. Now, if you're anything like me, I had a background in Excel and spreadsheets when I first started learning Tableau, and I struggled at the start. And I hope with what we share today, it makes that journey a little easier for you. Just a little bit about myself. I am a multi-time visionary with Tableau. I am also one of the ambassadors. I'm a forum ambassador, and maybe I've answered some of your questions out on the forum. I'm one of the co-founders and co-leaders of the Tableau newbie user group and also the Nashville Target. If you're anywhere in and around Nashville, we'd love to have you become a member of the Nashville Club, and we can talk about that later. When I first started my journey with Tableau, I had a client that came to me and said, I want you to learn Tableau, and it's exactly like Excel. And as we all know, nothing could be further from the truth than that. And after struggling for a while, I found out that there were four basic topic areas that I really had to understand before I could use Tableau effectively. And those were how to connect data sources together. The second was the sequence that Tableau goes through every time it creates a worksheet. The third would be how to customize calculations to get Tableau to do what I wanted it to do. And then the fourth had to do with the user interface and how users could change data using filters, sets, and parameters. And we're going to look in those four areas today. We're going to start with connections. And I find that most users who have a background in spreadsheet calculators will come and say, hey, how do I do a VLOOKUP? I've got two separate tables. I've got a sales table. I've got a quantity table, and I want to get those the sales and quantities to match up. Well, with Tableau, you do that with a relationship or a join. They're slightly different, but you can think of them doing the same type of thing. We're going to add a column of data to our data table. And I've got two sets of data. One is a sales data table, and all I got is product, customer, and sales dollars. And the other is a quantity data table, and I got the same thing, product, customer, and quantity. And all I want to do is I want to get the quantities to match up with the sales. And we do that with a relationship or a connection. And we have to match the customer in the sales data set with the customer in the quantity data set. And I do that just by opening this up. And I match the product in the sales data set with the product in the quantity data set. And now they're matched up, and I can calculate things like the average selling price. And the average selling price is nothing more than our sales, the sum of sales divided by the sum of quantity. Well, that works fine. And for the most part, that's what you really need to, the first type of connection you really need to know. But you also need to know what happens when I've got additional data that I've got to add into that data set. And if you're like me, coming from a business background, you would have gotten the second month's worth of sales, and you would have had to append that to your Excel file or to your Access database. Now, in Tableau, we use a union. Create a union between the sales data and then a union in the quantity file, and then we create that relationship. And I'm going to go back out to that data source tab again. And to create a union, it's really very simple. I just open up the file itself, and I either create a union, or in this case, I'm going to edit a union just to show you what I did. And I've got the first set of data, and I union it with the second set of data for sales, and I do the same thing for quantity. And now the relationship or the connection between the two is, once again, customer to customer, product to product. But I also need to calculate date to date. And I want to look at the month. I'm creating a calculated field here. And all I'm doing is I want to take a look at the month of the data in the sales data set and do the same thing in the quantity data set and connect those together on that basis. And when we do that, we can go back out to our file and we can take a look at our ASP again. And we can see it's the same formula, just sum of sales divided by sum of quantity. And that will allow us to look at the ASP in January, ASP in February, and the overall ISP. Now, those are the two primary connections that you have to worry about and you have to deal with. And Granted, it can get much, much more complex than that as you start getting deeper and deeper with multiple files. And you just have to work through and practice how to make those connections together. There's a third type of connection that you will run into sometimes, and that's when you have data coming from different data sources or there are different levels of aggregation. And for those type of data, if you try to union the data or use a relationship, you'll get an error message that says, hey, I can't do that inside Tableau. Now, you can do it in prep. And I'm going to advise you that that's a real good way to go, and I use it in prep every chance I get. But we have data coming from different data sources, like an Access database or from, and a second set from like Excel. You'd have to create a blend between the two data sets. And that's done very simply. I've got my first data set. I'm going to open that up so you can see what it is. That's just the data set we've been looking at. We got customer, we got product, we got quantity and sales, and I've already created that. And I've got a second data set, which is going to be my secondary data set. And that data set is nothing more than product and year and a sales goal. So I got a sales goal for each product for each year. And the only field that these two have in common, that these two data sets have in common, is product. So we can connect them on product right here. You can see they're connected together. And now I can use that blended data set, that blended target data set, sales target data set with my original data, and we can do some calculations with it. Now I'm going to tell you there's some limitations, and we'll get into those limitations a bit later. But I can take a look at first what my sales goals are, and I can break that down by month just by taking the sum of sales. And this is one of the, excuse me, this is one of the limitations. All the data coming from the secondary data source is going to be aggregated. So it's going to be aggregated, and the default is sum. So I take the sum of the sales goals divided by 12, and then I can use that value to calculate the percent of total, and that's the sum of sales divided by that value that we just looked at on a 12-month basis. Now, I'm going to show you later that we can't filter across the data, the two data sets, and we can't use LODs, and we can't use sets, and we can't use some of the other functionality of Tableau. And that's one of the limiting factors using blended data. Now, what I usually tell people when I get a question about it is, let's find a way to not use blending and to use a relationship or to use a union. And if you can't do it in Tableau, you can definitely do it in prep and then Tableau prep and bring that data into Tableau proper. Okay, so we now understand there's three types of connections that we have to deal with. Well, how does Tableau go about using that data to create each one of your individual worksheets? Well, that involves what's known as the order of operation. And that's just the sequence that Tableau goes through, the ordered steps that it goes through each time you create a worksheet. And what is actually happening is you load data into Tableau. You've loaded a data set. I don't care where it comes from, if it comes from a flat file or from a database. You've loaded that data into Tableau, and now you've got it in Tableau. Now, for each one of your worksheets, you're going to use a subset of that data. And that subset of the data, you can think of it kind of like an Excel spreadsheet. Now, it really doesn't look like that, but you can think of it that same way. You create the structure for that subset by dragging dimensions to the rows and to the columns, and by filtering those dimensions. And that forms the structure for the data set. And it's going to be a subset of the total that you loaded into Tableau. And then the rest of the order of operation just loads that data set with values. We do some math, and we decide what the business is going to look like. Now, I like to use this 10-step model for the order of operation. I know there's other models out there, but I like to use this one because I can break it down. I can break the individual steps into three groups. The first two steps, data extract filters and data source filters, are applied at the workbook level, and they filter data out of the out of Tableau as it's uploaded. And if you have less data, if you don't need the data, don't bother putting it in Tableau and filter it out, and it'll make your workbook more efficient. Now, the other 8 steps are done at the worksheet level. Each one of your worksheets has a separate data table. And that separate data table, as we just said, is the subset of the total data that you brought into Tableau. Now, steps 3, 4, and 5, context filters, the creations of set, fixed LODs, top end, and the application of dimension filters form the structure for the data table on that worksheet. The remaining 5 steps load that data table with values, we do some math, and we create the actual biz itself. It's important to note the data blending. We talked about that blending connection. Data blending takes place after the context filters, dimension filters are applied, the structure of the data table is created, your sets are created, fixed LODs are calculated, and top end is calculated. So blending is not consistent with creation of sets, fixed LODs, and top end. And you won't be able to use those if you use blended data, but you will be able to use them with any other type of connection. Let's go on and take a real quick look at these first 2. I like to use the Superstore data set. It's the same data set you got with your copy of Tableau. You'll find in there's about 10,000 records, a total $2.3 million worth of sales. Now, if I wanted to apply some context filters to this and I wanted to limit the amount of data, I'd go to the data source tab right here. I've got to wait a second while it opens up. Okay. And I want to add a context filter. I'm just going to add it. We can add a filter. I want to do that on category. And I only want to keep the furniture data. And that's all I want to show you today. So we're going to do that. And you can see here that this says we're going to keep furniture. Okay. Now you see here, I've got 10,000 rows of data. As soon as I connect this, you'll see I no longer have 10,000 rows of data. In Tableau, I've got 2,200 rows of data. And if we were to go back out to that tab that we were just on to look at this, we'd see we've got 2,200 as the count of the rows of data, and it's not $2.3 million worth of sales, it's $754,000 worth of sales. And that's the only data that's available in the entire work. Now, I'm just going to back out of this because I really need all those rows for the rest of the presentation this morning. You can see we're back at 10,000 rows of data. I want to spend one moment here this morning talking about context filters because it's so important. This is the area where we see more errors and more users being confused on application of context filters, when to apply them and when not to apply them. All right, and to do this, I'm using that Superstore data again. All I've done is I've got category, now I've got subcategory. And along with that, I have created a couple of LOD expressions. First, I've got this expression that in words, it says for each category, sum the sales. So all this does is create a total for each category. And you can see here for furniture category, the total of the individual subcategories is 754,000, and that's the total for the LOD. For office supplies, it's 731, and for technology, it's 839. And then I use that calculation to calculate the percent of the total at the category level. And all this expression does is it takes the sum of sales, this number, and divide it by that LOD that we just calculated. So this number divided by that number. Now I want to apply some filters, and I put a filter out here on subcategory. And we can apply that filter in 2 ways. First, we're going to apply that filter as a dimension filter. It's being filtered after the LOD is calculated. The LOD is calculated here. The fixed LOD is calculated in step 4. We're going to apply that filter after the LOD is calculated. And when I take bookcases out, we can see that the total sales in that category is now $639,000, But the LOD has been unaffected because the LOD was calculated before the filter was applied. Likewise, if we wanted to apply the filter before the LOD is calculated, we would come back and apply it as a context filter. Okay. Now, when I take bookcases out, we can see that the total for the three categories is 639,000. And the LOD now calculates the total for furniture at 639,000. That happened because we applied this filter. We took bookcases out before we calculated the LOD. Now we'll have users come in and say, hey, I want a calculation that ignores the filter. Tableau doesn't ignore any of the filters or any of the data that you've got in your data set. You decide when you want to apply that filter. If you want the LOD calculated after filter is applied, apply the filter in context. If you want the LOD calculated before the filter is applied, then apply the filter as a dimension filter. Okay, I want to move on now, and I want to take a look at different types of calculations. Okay, and if you were to go out and you were to look at all the calculations that are available out there, it's formidable. I mean, it's just kind of mind-boggling about all the different types of calculations you can do. And that's a good thing because it gives you lots and lots of flexibility. But if we were to take a look at those calculations, we would see that they break down into four different types of groups. There's the simple calculations that include if statements. There's date functions and how you deal with dates, and I'm talking about real dates here. Okay, there's LOD expressions, and we've just had a couple of examples of LOD expressions, but level of detail expressions, and then there's table calculations. We're going to look at each one of these separately. If we were to take a look first at simple calculations, I want to create a simple calculation to calculate that ASP that we've been looking at, the average selling price. Now we can create that by opening up this drop-down, and you can see it says create calculated field, and I open that up, and this wizard opens up. And you can see here, I've got a place where I can create the calculation. I'm just going to first give it a name. And I'm going to call that ASP. And with that, I have a number of functions that I can choose from, and all the functions are listed here. Okay, and I can sort them, or I can use, I can look at groups of them. And for each one of these functions, I've got over in this pane, it tells me how to use that function and what to do with that function. Well, we're not going to use the cosine. What we're going to do is, we saw before, we want to take the sum. And you can see as I type in to this field here, the Tableau suggests values that I can put in there. I want to take the sum of sales, and I want to divide it by quantity. And as soon as I do that, as soon as I divide it by quantity, I get an error message, and that error message very simply says I can't mix aggregates and non-aggregates. And this is probably the most frequent error that you're going to see out there. I'm going to show you how that comes about and what it really means. If I were to take a look at this data set and open up view data here, you can see that there are 24 rows of data. The way that Tableau would look at this, there's 24 rows of data in this data set right there. The underlying data, the record level data, if you will, for this data is 10,000 rows of data. Okay, and all this message is telling us is it's come back and it's telling us, it's to say, wait a minute, I've got the sum of sales, and that's 24 rows of data, 24 records that I got to deal with. And this thing is 10,000 rows of data. They're not at the same level. It's got to be at the same level. And we can do that with a number of different aggregations, but the one we're going to use here is sum of quantity that gives us the ASP that we've seen before. And now we're looking at our average selling price, and it's calculated properly. If then statements are also fall in that category that I call simple calculations, and they're very easy to deal with. You've used if statements in Excel all the time. All you have to do is learn the syntax here, and the syntax is different. This syntax in Tableau starts out if the category equals furniture, and I've got three categories: furniture, office, supplies, and technology. Well, if it equals furniture, then sales. So you see, when I apply that, I got furniture sales, and everything else, zero. Well, I have zeros for everything else. I can change this calculation, and I can add to this calculation. I can, for example, I could say, or I can use a conjunction, or the region equals east, then sales. And if I apply that, now you can see that for all the furniture category, I have sales. For all of east, I have sales. Or I could have used and. So now both of these conditions have to be true. I have to have category equals furniture, and I have to have east or a region. And when I apply that, there's only one value that meets both of those criteria. Using if statements is only slightly different than what you're used to. It's just a syntax difference, and you get to know that syntax and use that syntax as you gain more experience. I want to go over and look at date functions, and dates are a very special class of dimension in Tableau. The dates themselves are real dates and not strings, have some unique properties to them. They self-sequence and they self-sort. So that when you start using dates and you start using date calculation, real dates will work in date functions where strings that look like dates will not. And that's real important that we always use real dates whenever we have the opportunity to do it. Now, the good news is it's very similar to what you already do. The same concept of how dates are created in Tableau is the same way it's done in Excel or any spreadsheet calculator. There's a whole number embedded in Tableau that represents the date way in the past, and that whole number can be represented by a hierarchy, and that hierarchy looks at the year, quarter, month, day. Now think of a decimal point going right here. That's the whole number part, and then the decimal part is the decimal part of a 24-hour day broken down by hour, minute, and second. Each day, this number increments by one value. Now, I'm going to let you in on a secret here. For some reason, the Tableau day and the Excel day are 2 days off, and I really don't quite know why. There are 3 additional date parts that aren't part of this hierarchy, and you're going to use them quite often, or at least 2 of them you're going to use quite often. One is the week, because weeks don't line up with the start of months, and they don't line up with the first of the quarter or anything like that. Weekday, Monday, Tuesday, Wednesday, Thursday, Friday, that sort of thing. And this one that's not as well known or used, but I use it quite often, is day of the year. The first day of the year, January 1st, is 1. The last day of the year, December 31st, is 365, except for this year, it's 366. And Tableau knows all about leap year. So this becomes a very useful function also. Well, I like to look at date functions in 4 groups based on what the function returns. There are those functions that return real dates, and those functions include date trunc and date parse, and then 2 additional functions that are used to convert strings to dates, and that's make date or date. Another group are those that return a reference to the date. It's not the date itself, but it's a reference to the date. Like date name would be like January, February, March. Date part for that same sequence is 1 for January, 12 for December. So date part returns an integer value that's related to the date. Then a year, month, and day, pretty self-explanatory. It's the same type of function that you use in Excel and then weeks and day of the year. There's also those functions, and there's two functions that do date names. If we want to increment a date, like if we want to use last year, we would use date add year minus one date. If we wanted to take the difference between two dates, we could take the two dates and we would use date diff, month, the first date and the second date, and it will return the integer value of the difference between those two date months. And then there's two functions. There's special functions. There's today and there's now. And today returns the date of today, and now returns the date time, and that's set by your system clock. Now, date functions pretty much have the same syntax across the board. When you write the function, it starts out with the function name, like date name, and then inside the parentheses, the first argument is the date level from that hierarchy: year, month, day of the year, week. That value is always enclosed in quotes. It's always singular, and it's always lowercase. We don't have months, we have month. The next argument is the real date dimension from your data. What dimension do you want the function to work on? And then this last value is optional, and that's the start of the week. If you don't put it in the US, and it will default to weeks starting on Sunday. In Europe and most of Europe, it will default to Monday. But you can change that. If you want your week to start on Wednesday, you can put that in. And once again, it'd be singular, lowercase. If you wanted to start on Wednesday, inside quotes, you'd put Wednesday in lowercase. Okay. Let's take a look at how some of this works. I know it's easier to see real examples than to just talk about them. We have the one that we've been talking about, and this is the way it would look. The date name, and if we wanted to see what the date name was, date name, and this is how the function works. It returns part of the given date. Okay, it returns an integer value. Okay, so we're going to take a look at the date, or I'm sorry, the date name is going to return a text value. And we're going to look at the month level, and we're going to look at the order date. And that's this value right here. It's January, February, March, April, and so on. We could have looked at date part, where I got a little ahead of myself. We could look at date part month, and it returns a reference to that. That is the integer value 1, 2, 3, 4. 1 for January, 12 for December. I could have looked at quarter. And if we look at quarter, we'd see that for January, February, and March, that's the first quarter. For April, May, and June, that's the second quarter, and so on. Date trunc is a function that I use a lot, and I like to use it a lot. Maybe it's because my background as an engineer, I like to get down into the detail on equations and functions. The date trunc is a function that returns the first day, or the first record of the period. So we can look here at the date trunc for the month of the order date, and for all the records that have January and the year associated with that January, in this case, January 2023, they'll all have the same date trunc month of January 1st, and February 1st for February, April 1st for April, and so on. If I wanted to look at quarter here, we would see that for January, February, and March, all those values have January 1st as their date trunc value. The second quarter all have April 1st as their date trunc value. Now, I use date trunc a lot when I want to do year-to-date calculations and year-over-year calculations, or period-over-period calculations. I like to use date part and date names when I'm applying labels. Other people have different approaches, but that's fine. You find what works for you best and what you're most comfortable with, and use it consistently, and you'll get really good at it. I want to move on to the next topic, and that's LOD expressions I love LOD expressions, and I do tend to overuse LOD expressions. I want you to think of your data as as a pyramid. And the data that you entered into Tableau, that 10,000 record level of data, is the lowest level of that pyramid. It's like the base of your pyramid. And sometimes that's referred to as the grain of the data. Now you can total that data up to one value. And that would be like the tip of the pyramid, the top of the pyramid. So I got one value at the top, I got 10,000 values at the bottom. But there's times when I'd like to have additional layers in that data set. And that's what fixed LODs allow you to do. I could create a LOD expression here that in words you would say for each region, sum the sales. And there's 4 regions, so I would have 4 values. And that's a level, a different level in that data set. Or I could say, well, I want region and segment. There's 3 segments and 4 regions. And in words, you'd say, well, take all the combinations of region and segment. That's 4 times 3, that's 12 values. Sum the sales and save it so I can use it later. So now I'd have four levels in my data structure. That the beauty behind fixed LODs is that they are not aggregates in themselves, and I can use those just like I'd use any other data in any form of expression or any form of calculation. Let's just take a real quick look here. I've got in this table, I just have my sales by subcategory and by year. And I would like to do is make this calculation. And I want to look at every combination of year of order date, that's 4 values, and subcategory, that's 17 values. So there's 68 values, 4 times 17 is 68 values. For each one of those, sum the sales and save it so I can use it. And then as my denominator, I want to look at the 4 values that represent the total for each year, the sum of the sales for each year. And you can see when I do the division here, I take my numerator and I have to aggregate it because the LOD is not aggregated in itself. I sum the numerator divided by the sum of the denominator, and I get for each year, each subcategory, it's percent of total, and it totals 100% for each year. I want to move on to table calculations, and for people coming from a spreadsheet background, they're usually most comfortable coming to Tableau using table calculations because they're very similar to what you've been doing. You think about what you've done in Excel, for example, you write an expression, write a formula in a cell, and then you take that expression and you copy it and you paste it across the columns or down the rows. Well, table calculations work the same way, except we talk in terms of scope and direction. Scope is how much of the table is used in the calculation, and direction is across or down in terms of direction. There's also 5 functions that can be used to navigate the table and can be used in other table calculations. Those 5 functions are first and last, and they refer to the first row or column in the data set or the data table, and the last row or column in the data table. Index, which just counts across the columns or down the rows. Lookup is like offset in Excel. You just start at one cell and offset to another cell and return the value that's there. And previous value just looks at the previous cell worth of data. We're going to take a look very quickly at how some table calculations can be calculated. I've got sales data, and if I wanted to calculate a quick table calculation, I can open up this caret, looking down, go to quick table calculation, and I see that Tableau has a number of different functions that are already available, and I can take the percent of total, and the percent of total down will give me the percent of total starting by each category all the way down to 100% at the bottom. But that may not be what I wanted. I might want to edit that table calculation, and I don't want to look at the table down. I want to look at the pane down. And by pane, I want to look at all the furniture data, and I want it to total 100% for furniture data. 100% for office supplies and 100% for technology. And I could do that also. I want to release this just very quickly. And I'm going to clear that table calculation. Whoops. Yeah, there we go. Now I've created a running total just to show you a different type of table calculation and show you what this does. And this running total is just a table calculation. We can go over here and we can see running sum, but there's also different calculations. I can get the running average, running count, the running min, running max. But I took running total, running sum, and notice that I have to use the sum of sales because we're not looking at the 10,000 record level when we do table calculations. We're looking at the data that you see or the 17 rows worth of data that you see. So a running total this value is just the sum of those two values, and this value is the sum of those three values, and so on, all the way down the table. Once again, if I didn't want to see it that way, if I wanted to see that based on the pane down, I could see that this is now the sum of all four categories that make up furniture. And then we start over again for office supplies. So you'll become very quickly, you'll become familiar with table calculations. They're the ones that are most familiar to you. I want to show you how we do some of the navigation calculations. And I want to take a look here at a lookup example. And all this does, and the way you would read the syntax in words, is you say, well, in that column that's called sales, oh, well, that's this guy here. I want to go from the cell that I'm in to the previous cell. So I'm here in row 2, and I want to go to row 1, but I want it to come out of the sales column. So it's that value there, the 167,000, or the 108,000, or the 27,000. I could, for example, have looked at the first value, and I want that first value over and over again. I want that 167,000 in each row. Now, I could also create a calculation based on this that just looked at the dividing this column by this column by that column. Okay, and in doing that, we can, and I want to change that to %, and we can add that to our chart. You can nest table calculations inside other table calculations. You can use table calculations inside other table calculations, but you cannot use the results of table calculations in LOD expressions or simple calculations because they are not calculated until the 10th step of the order of operation, where LOD, for example, are calculated in step 4. Okay. Now, I want to take a look at that last category, and that's the user interface. That's where you allow the user to make a lot of changes in your dashboard. And we're going to take a look at three different types of user interface: filters, sets, and parameters. Now, we've already looked at 4 of the 6 types of filters. There's 6 types of filters in Tableau. We've looked at 4 of them already. We've looked at types 1 and 2, the data source and data extract filters. We've looked at context filters and dimension filters. Now we're going to take a look at measure filters, which are step 5 that are used in step 8 of the order of operation, and table calculation filters that are used last. And they are the only calculation, they're the only type of filter that can be used on a table calculation without affecting the underlying table for that calculation. I have a table here that it's just our sales by date and by year, and we're taking a look at the sum of sales. And I want to put a measure filter, and all I'm doing is holding the control key and moving this up to a filter. And when I do that, this box opens up. And I have a choice at which level I want to apply the measure filter. This top is called all values. I don't like this name. I would say at the record level, or you can think of it at the 10,000 record level today. Or we can look at some sort of aggregation, and we're going to take a look at sum, for example. And that is a level that is at the, we'll say like 17 level. It's much more than 17 in this particular chart, but at the aggregated level that you're showing in your data table. So let's just take a look at sum. And we can see here that the values range from a little over 3 to 146,000. And we can put that, oops, what happened? Okay, we're going to take a look at sum. We're going to take, and we're going to put that in. Okay, and I want to show the filter. And I'm just going to drag that over here. I can change this. I want to look at values that are only greater than 10,000. And we'll see that all the values on this chart in total for each combination of date and the year of order date are greater than $10,000. I could have used a different example where we look at the record level, and we're going to once again show that filter. And I want only values greater than 10,000 at the individual record level. And when I do that, we can see that there are only these 5 values that have individual records greater than 10,000. And we filtered out the other data. Well, that's how you go about using a measure filter. And you could use any sort of aggregation. You didn't have to use sum. You could use standard deviation or whatever. Now let's take an example of the last type of filter, and that's the table calculation filter. I use them mostly for showing and hiding data from the table itself. Very frequently, we'll get users have come and they've said, look, I've got a running total, and I'm just going to create a running total, a quick calculation, a running total. I've got a running total, and it starts in January of 2020, and it runs all the way through 2023. And all I want to see is the last year, but I don't want it to start at 0. And if I just put year on filter, it's going to reset the thing, and I'm going to look at 2023, and it's going to start at 0. And we know now that's because if I use year on the filter, it's a dimension filter that's applied in step 5. What type of filter can I use that won't affect that data table? And that's a table calculation filter. And the calculation I wrote here is I say if last, and last is a table calculation, is less than or equal to 11, and it just so happens that last, this right-hand column, the value for last for that column is 0, and they increment in a positive direction going to the left. So if last is less than or equal to 11, it's 12 values. Then show, else hide, and I like to spell out show and hide. So later, when I come back to this, I will remember when I'm done. And then when I just look at the show values, I'm looking at the last 12 values, but they're starting at the 1600 that was in January 2023 and goes through December 2023. Filters filter data out of the data set. Sets, on the other hand, divide the data in the data sets into 2 categories: what's in the set and what's out of the set. No data is eliminated from the data set. So we can use the entire data set even though we have applied a set or set filters. I have created a set on subcategory using a parameter. And I want to show you this parameter. It's just a simple floating point number, and I placed it right here, and I've set the value to start with the $20,000. Then I've created a set based on that value. And I've come to the set. When I created the set on subcategory, I've come to the condition. I've selected the condition. I want sales greater than this parameter value. So I've got what is in the set greater than 20,000 and what's out of the set, but I have all the values. We haven't lost anything. We could reset this to 150,000. Count my zeros there. And we can see that now my inset are all these that are greater than 150,000, and the outset are those that are less than 150,000. And you can see that none of them are greater than 150,000, but I haven't lost any values. Well, what would I do with this, and how would I go about using it? Well, I've created a different set here using the same sort of concept. I've got a parameter here. And this one, I wanted to show you how to use this parameter. And it's an integer parameter. And right now I've got it set at 5. Okay. And I've created, based on this, a set. And now I'm on the top tab of the, when I created the set on subcategory. I want the top in these values right here, okay, based on the sum of sales. So now I'm looking at the top 5 values. I could look at the top 7 values based on the sum of sales. And you can see I've got what's in the set, but I also have what's out of the set. So we know what the total value is. I could also take this and make it a quick calculation and take a look at the percent of total. And we can look across the table. And now we know that the top 7 make up about 65% of the East region. Okay, this is typically known as proportional brushing. Okay, that's how sets work. They're very easy to use. We've taken a look at some parameters. I just want to talk about parameters here so that you understand about parameters. There's 3 things you have to know about parameters. First of all, parameters are single value. They only have one value at a time, and the values change manually by the user. The second thing you need to know about sets is that value is global. It's the same value throughout the entire workbook. And the third thing that you need to know is that parameters don't do anything. Parameter value itself is just a value. And it has to be used in a filter, it has to be used in a calculation, and it's a filter or the calculation that does something. We'll take a real quick look at what I've set up here. And I've created a parameter, a subcase parameter, and this happens to be a string parameter based on the name of the subcategory. And I just created this directly from the data. But I've come back and I've added a value called all. And I keyed this in, all, A-L-L. And I've created a filter based on that parameter. It's a Boolean, a true false. And I say if the subcategory equals the parameter value or the subcategory equals all, return a true. And then I place that up here on the filter shell. And I've set it to true because I only want to see the true values. And using this, we can look at all the values, or we can look at any one of the values, or we can come back and see all the values all at once. Well, why do we do all this stuff? These are pretty simple, basic functions and pretty easy to do. Well, we do it because we can come back and we can start making pretty complicated dashboards and worksheets that are really nothing more than combinations of what we've seen today. Very simple calculations and user interactions and functions like filters and sets and the like. This dashboard will allow us to take a look at the year-over-year growth, if you will, the current year versus the prior year in dollars and in percent. We can take a look at the top 5 categories. We can set the end date. Right now, we're looking at years 2022 and 23. We could look at 21 and 22, for example, or we could look at 21 and 20, or back to 23 and 21. This is driven by a parameter and a parameter action, and I'm going to show you that parameter action in a second. We can also look at individual states. We're looking at the entire United States, but if we wanted to just look at California, I could select California. That's done with a set and a set action. This calculation is nothing more than the top end calculation that we looked at before. Let's take a look at just real quickly the actions that go in here. I've got dashboard actions. I've got 2 actions on this dashboard. One is a set action, and I can change the set from the map by selecting the set either individually or using a lasso, or I can change the parameter in this one, going from the value picker right here. When I select it, I'm changing a parameter value to the year of the order date. And that's all we're doing in this value. And if we wanted to take a look at the year-over-year calculation, here, the year-over-year calculation for the current year, and I'm just going to open one of these in the interest of time. All this does is it's a fixed LOD that we learned about earlier. And all this says is if for each state in the set, the state set, if the state is in the set and the year of the order and for each year of order date, if it equals the year that I've selected for the order date, then record the sales. And similarly, for the prior year, we did the same sort of thing, except we just look at the year of that parameter for the order date -1. And then we can do the year-over-year calculation. It's very simple at that point. And the top end calculation is nothing more than the top end filter, where we've used right here a parameter to set the top values. We could look at 7 if we were to so choose. Okay. Now, so what we've done today is we've taken a look at some very simple, straightforward examples on how to connect data, the order of operation, calculations, and the user interface. The way you're going to get good at Tableau is by using them frequently. Don't be afraid of them. Practice with them. Learn from what you're doing in the process. It's certainly what I did. Very glad to spend time with you today. I would suggest to you that maybe a good place to learn more about Tableau is with the Tableau Newbie User Group. You're certainly welcome to join us at the user group. We meet 7 times a year. And if you have any questions for me, you can reach out to me at my blog or my website. I also have most of this stuff now recorded as YouTube videos. Thank you very much for your time. Bye now.